Welcome to our webinar. This session will be recorded for the people who were not able to attend at this time. Feel free to address questions during the presentation in our chat or directly to me. My name is Mihai Nagoe, and I'm Operations Manager within Wayfair. This webinar is our third, and yeah, we have listened to your feedback to prepare a more technical type of presentation. Today we're going to discuss about domain models and how we can engineer solutions for projects using them. And first, yeah, a short introduction about Wayfair. We're located in Cluj-Napoca, northwestern part of Romania, and we build long-term collaborations on different technologies, with our core being on Progress Upon Edge and web technologies. We offer a full life cycle support on our projects, and we are proud of being for more than 11 years in activity and recently passing the 100 team members mark. Our growth is organic, and we put a lot of effort into trainings and raising the new generation of developers who are joining us every year. Now, I want to introduce Cătălin, one of our talented developers, passionate about programming and domain models in particular, who is going to present the concept behind and a small demo from his implementation. Now, a big woof to you, Cătălin.
Thank you, Mihai, and hello, everyone. So first, let me present myself. So my name is Cătălin Moldovan. I've graduated master studies last year with a master's degree in computer software engineering. And I've joined Wayfair 2 years ago. And right after that, I started working on an OpenEdge-based project. As hobbies, I play squash, tennis, and before the pandemic, I did some skydiving and gliding courses. Other things about me, I have a Shiba Inu, a lovely dog. His name is Dino, and well, you know, he's unemployed, of course. But we have one thing in common, we both like pizza. So for this webinar, I structured this presentation in 4 parts. First, I will introduce the concepts of model-driven engineering approach in software development. Then in the second part, we will see what are the benefits of using domain models for our project. And then I will present to you the tools, the modeling tools for creating and maintaining a modeling project. We will also have a short demo at the end. I will show you how a modeling project can be used with OpenEdge. So let's get started. We'll start with an introduction. So what is model-driven engineering? In short, MDE. Well, MDE is a method to design software faster, cheaper, and more efficiently. It also provides a better understanding of a complex system. The idea of MDE is to raise the level of abstraction of the system, and this way we can represent our requirements visually. So we can use diagrams, sequence diagrams, tables, or other types of representations. And I'll explain some of the concepts with an example. Well, I've already told you that my dog likes pizza. So let's build a machine that creates all kinds of pizza with different toppings. And we call this the system, which is an idea of the product. That's basically our starting point. Once we have the plan, we need the main ingredients. Like we need the dough for the pizza, we need ketchup, and we also need some vegetables. And these are some basic building blocks that are part of our base model. Those are the essential elements for making our pizza. Then in the next phase, we use all these elements, all these ingredients from the base model to make our pizza. And this is our model. Our model describes the structure and behavior of our system. But in this case, we only put some ingredients together, but the pizza is not yet ready. So the final process is to bake the pizza. So we put the pizza in the oven, and then we can say that the pizza is ready, hot and tasty. And yes, this is our product. That's the final result from the model. Now, if we want, we can make another pizza, like a pizza with more pepperoni, with more cheese. And to do that, we just have to change the model, and then we'll have another pizza. The modeling project has multiple stages. And if you look on the presentation from the left side to the right, first we have a meta-meta model, which is also called E-core. This is the foundation. It is the first model that describes the entities, the relationships, and the properties of the unified modeling language. We use this to create the meta model, which is also called base model. Then we use the elements from the meta model to design our user model. So the user model is an instance of the meta model, and the meta model is an instance of the meta-meta model. So the idea of MDE is for a programmer or non-programmer to get involved in the development process with or without programming knowledge. And let's do a comparison. So in the traditional method, we have a chef, which is like an experienced developer. So he knows the recipe and he uses his ingredients to make the pizza. In this case, a developer has to write the technical documentation for the new functionality. Then he has to write the code for it. And this process takes quite some time. And also the developer has to have knowledge on the project and also to have some experience in programming. And on the other side, we have the smart guy. This smart guy can be a programmer or even a non-programmer. When the smart guy wants a pizza, well, he can just order one from the nearest restaurant. And let's say that they already have some pizzas ready and the delivery is fast. So in this case, the user just have to create a functional representation of the new functionality. And then he just have to generate the code and the documentation from that representation. And this process takes less time, and it is also easy to represent, and it might not require to have experience in programming. Now, let's look at this picture. So in practice, we can describe the modeling project in three parts. If we are looking on the top layer, the requirements are presented using the base model, which describes our components. Then we represent the system through the model by designing it using a graphical viewport. And in the end, we can generate the source code, which can be business logic code, unit tests, security rights, and also documentation, even other stuff, as a result from the created model, which is actually the resulted functionality. So you can see that the abstraction decreases from top to bottom, and the level of details increases as we reach the code level. Okay, and now let's move to the next chapter. So we'll see now how we can integrate model-driven engineering into a project. And let's see what is the planning. So the first point is to see exactly what processes can be automated. And I'll give you an example here. So for instance, if we want to use an open edge reference architecture for our project, we have to create some layers from data source. We have the data access, we need some business components, and then we have the presentation layer. And basically, this specific logic can be automated. The next point is to design the meta model. The meta model contains the generic tools for these processes that we want to automate. And well, this is simple. This is just an UML diagram. Then we have to prepare the environment. So we have to create a graphical user interface, and we can design it how we want. Then we have to create templates for the code that will be generated, and also some templates for the documentation, if we want documentation on our project. Optionally, we can prepare some model validations. In this step, we can define like some guidelines for the model. And then, well, that's it. Our modeling project is now ready to be used by developers or non-developers to add new features to the project. Now, let's see some of the advantages of integrating MDE in our project. So first, I will say that it is easy to be maintained. The hardest part here is to set the MDE project for the first time. But afterwards, we can do different improvements to the application. We can also adapt the requirements if you want. One other benefit is that we can automatically update hundreds of code files of the application without affecting other parts of code. So this is very good when you want to refactor the code. And another advantage is portability. Modeling tools are also available on both Windows and Linux platforms. And now some pros and cons for teams that are using MDE for developing their project. So for the development process, it definitely lowers the time spent on different tasks. So we can do more things on a project in a short period of time. Then by generating code, we can have like a standard application architecture. So in this case, the code, the business logic is consistent in the whole project. We can also get a visual representation of the main functionalities that are already implemented in the project. And this is very good for other people on the project, for instance, for a business analyst or for the IT management or maybe for testers. As for developers, well, they will be mainly focused on specific functionalities and not the base functionality. But here we have to encourage developers to make changes to the model and not to add manual code, because we want our model to reflect our code and also the code to reflect our model. And also for the code that is generated to be consistent with the other code in the project. Now, in terms of experience, for developers new on a project, due to system abstraction, they might not know how things are implemented. So they understand what the system does, but they do not know the logic behind. And here for experienced developers, well, they might prefer the traditional development rather than the automated one. And well, I think this is obvious because you code in your own way and you can also customize it how you want. But here we just have to encourage the developers to use the MD for the project. Okay, and now let's see the tools, the modeling tools that we can use for our modeling project. This is an overview of some of the main modeling tools that I would say any modeling project should use. And I've represented each of the framework with a planet because, well, they all have something special for our project. And besides that, they are all free to use. So right now we'll go through each framework. And yeah, I will start with a joke. So you know how people see the eclipse, the real eclipse. The last solar eclipse happened, well, almost 2 months ago. That was on 14th of October. And now the programmers, we see the eclipse way different than that. You are seeing at least once the loading page of Eclipse when we open the IDE. And for developers that are using OpenEdge, they see it as the Progress Developer Studio, well, which is actually an Eclipse instance. The Eclipse environment is very flexible. We can customize the interface and the user interaction exactly how we want. And we can also use Java services to add new buttons, to add new windows and all kinds of pop-up messages. So we can have info messages, warning messages, error messages. We've never seen aliens or dinosaurs, but have anyone seen developers finishing their task in less than 10 minutes? Well, I'll tell you, it is possible. The next one is EMF. EMF stands for Eclipse Modeling Framework. Just for you to know, all these modeling tools can be installed from the Eclipse marketplace, and they are very easy to find, and it's also easy to install. So the EMF, we use EMF to create our meta model. And as I've already told you, we have to create a new ML diagram, and we can create it very simple. We can just drag and drop some classes into the view, then we can add attributes into that class. And we can also define different relationships between these classes. And yeah, now let's get serious. The developer team can come with fancy diagram designs, which might look like Tetris, but well, this can be perfect for our project if it does what we want. Sirius is a graphical tool used to design our model, and we can represent our data from the model using diagrams, using tables, or even pictures. With Sirius, we can also add validation rules when we want to create our model. And here we have to use Axilo query language, which in short is AQL. We use it to navigate and query our model. And well, we can represent our model in lots of different ways. And I took some of the examples from the Sirius web page. So we can create something that looks like a mobile application, like a software application, we can also make it to look like some IoT devices. We can also have a state machine diagram. So we can choose how to represent it. And now comes the interesting part. So now we have our fancy model, and we can be smart and generate the code based on that model. And believe me, it doesn't take too long. It just a second. The idea of Axilio is, well, if you can write it, Axilio can generate it. So Axilio, Axilio is used to transform our model into code. But to be able to generate the code, we need some code templates as well. And these templates can be written in any programming language. But in our case, we can use OpenEdge, we can also use Java, Python, any kind of programming language. Here, we will also use AQL language to get the information from the model. And we can also use it to add different conditions into the template. And optionally, we can also use Java for more complex logic. Now, we as developers, we are asked many times to write documentation, and I know it's not an easy job, but the documentation is important. In some situations, it might be useful, and I would say that it is good to have one. It can be useful for all the team members, you never know. Here, Gendocs works very similar with Axilo. The only difference is that it generates documentation. So it can generate a Word documentation or a PowerPoint documentation, or even an Excel document. The same, it uses AQL language to get the information from the model. Now, you know Bob. Well, do you know who Bob is? Bob is working on a complex project for, let's say, for 3 years. And he suddenly wants to refactor the code. Like, he wants to do some renaming. He wants to rename some classes. He wants to change the case clauses with if clauses in the code. You know, he might introduce some bugs, but this should not stop us. And we can be like Bob and do all this stuff in a very short time. And we use QVTO for that. And we can use it without breaking anything in the code. So QVTO is good for complex projects. For instance, when we want to make some changes to the meta model. If you remember, I've already told you that the user model is an instance of the meta model. So if we are doing some changes on the meta model, this might break our model because it depends on it. But in this case, QVTO helps us to map the properties and relationships from the old model to the new meta model. So QVTO offers our project scalability. And the last one is OCL. You know, if your code doesn't work, then you can try and run it again. Maybe it will work. OCL is a verification tool. We use it to validate the model. OCL mainly looks for issues in our model, and we can also add all kinds of validations to our model, like semantic validations, property, view, design, data validations. Yes, so here we have like an overview of these tools. So as a recap, with EMF, we create our meta model, and this is just a UML diagram. Then we use Sirius, which is a graphical modeling tool, to create our model. Then, based on that model, we can generate code with Axilo, and we can also generate documentation with Gendoc. When we want to extend or update our meta model, or even refactoring the model, we use QVTO. And optionally, we can add some extra validation to our model with OCL. And now, what skills are required for an architect to design the modeling project? So first, he must know how to use a modeling language. So he should know how to navigate through the diagram components. And then if the project is an OpenEdge-based application, then the templates has to be written in ABL. And then we also have to use AQL to write the different logic and different rules for the code templates and for the documentation template. Java is used often for complex logic, so it's good to also know Java. And we also use it to personalize the user interaction. The last two, QVTO and OCL, those are two separate languages. So here we have a nice overview of how the modeling project works. And if you can observe, we have to use two Eclipse instances for our project, or two Developer Studio instances. So we have first the tool developer workspace, where the meta model is created using EMF. And then we have the end user workspace. Here we use the objects from the meta model to design our model with Sirius. Then we can generate the source code with Axilo and the documentation with Gendoc. With QVTO, we can perform a model-to-model transformation, and with OCL, we can validate our model. Okay, and now for the demo, I will present to you a prototype that I've created for an OpenEdge application, and I've also gave it a name. I called it Next OpenEdge Viewpoint Application Environment. In short, Nova environment. So let me open the application. So this is an example of the UML diagram for our OpenEdge project. I've already prepared something for this demo. So this is basically our meta model. So we can see that we have different classes in this UML diagram. Our project has a list of attributes like the name, a description, the database connection. And this project can have multiple entities. So we can have some temporary tables, we can have data sets, we can have an OERA object, and we can also have other different specific components for our project. And now, to be able to create our, or to design our model, we need to open a new instance of Eclipse. And now we just have to create our model. And for this demo, I will create a CRUD REST server for the customer table using the Sports 2000 database. So first, we need to connect to our Sports 2000 database. So we are loading the database schema. We can see that it was a success. Now we are connected to Sports 2000. And for our REST service, first we will need a temporary table. So I will just drag and drop the temporary table entity. Then I can choose from this drop down our table. So we will use customer. And we will also include a before table. And now we will need the data set. And we will just drag and drop our temporary table into the data set. And now to create an OERA architecture, we will just drag and drop an OERA component. And we will assign our data set to our OERA object. And we can see that our project, our OERA, has already the REST annotations for the customer. We will also add a note. And we will also include this note into the generated code. And I will assign it to the data set. Okay, I will just save the view. And now we can do all sorts of things. For instance, we can generate the business logic, we can generate unit test. So what you can see here in this properties window, those were customized by me. So you can customize it how you want. You can add different features here. And for this demo, I prepared here some projects for our application. So I have here a project for the unit tests, which is an empty folder. a project for the business logic, and I've also created a project with the password tools already in the project. So first, let's generate our application. So we will just generate our code based on the model that we have created. And the generation was complete. So now we can see that in our project, it generated some support files, and for the customer, we have different classes for the REST application, and we also have the include files. So if we open the include file for the temporary table, we can see that it defines the temporary table for our customer. It also includes a before table, and we also have all the fields and indexes from the database. For the data set, well, this one is very simple because it includes the temporary table, it defines the data set, and we can also see the node that I've added in the model. Now, if we have a look at the classes that were generated, let's have a look on the presentation layer. So this is a service interface for our customer, and you can see that it already generated this class with the annotations for the REST service. So we have for this class methods for fetching the data from the database, fetching the data with some conditions. We can also create records, update records, and also delete records. So basically, with our model, we have generated an application from zero. And we can also test this application. So I will just copy this file into our Era project, into our so we paste it here. Okay, and let's start the password server. But while we're waiting for the password server to start, we can also generate, for instance, unit test based on the same model. So we generate unit test, and we can see that it generated unit test for our customer. We also have a test data folder. It was also generated a procedure for mocking the data for the customer that we can run in order to have some dummy data. And we can also open the XML file. And we can see here that we have some test data for our test classes. And we can also have a look at some of the test classes. So we have here a unit test class for the business entity of the customer. And you can see that our generator just prepared the unit test. So we have to do some changes to this unit test, but the code is already prepared here. We just have to do some small adaptation to add some data. We can also have a look at the customer on the validate class of the customer. So the password server started. Okay, so now we can test our REST service. So I already prepared here the Postman with some requests. So first, I will do just a fetch on the database to get all the data from the database. And we can see that we get lots of data. Can we also see it more? Okay, no, it's better. So we can see that we have here one record. This is the first record of the customer. The name is Lift Tours. And now we can use another request to make some changes to this data. Lift Tours webinar. Okay, and now let's fetch again the data so we can see that the first record was updated with the name that I gave. We can also fetch some other data with some conditions. So we can have like all the data, the first 7 data, and the country to be USA. And you can see that we managed to fetch 2 records, and the country is USA. So our application works. And now I also want to show you how we can generate documentation based on our model. I have prepared a template for that. So based on the same model that I've created, we can also generate a documentation. And for that, we will use GenDoc. Okay, and it's ready. And the file was generated in a folder, and we can open our documentation. And we can see that this is just an example of how the documentation looks like. We have information about the generated document, who generated it. We also have a table of contents that we can update it. And well, we have in our documentation first a model diagram. So this is exactly the model that I've created. And now we have a picture of it in our documentation. We also have a table with all the components from the model. We also have here a list with all the project classes that were generated. And then we can see different types of information for our generated code. For instance, for our temp table, we can also see here our data set that was generated and our node that, so we can also see the node that we have added in the model. And yes, we have here all the type of other informations like the classes, the methods that were generated, information about the validation classes, about the support files that were generated. And we can also have some information about the unit tests that were generated, the methods name, and some other information about the unit tests. Yeah, so that was the demo. Let me go back to the presentation. So, do you have questions?
I see we have a couple of questions. Yes, please, Marcus.
Yes, one question for your example you just showed us. How does it look like when you have referenced data, for example, the orders of the customer? How are they linked within this JSON code? With an URL or with an sub table, or how does it look like?
Well, this is an example where this is just a prototype. For now, well, the idea is that with MDE, you can create the modeling project how you want. For instance, for this OpenEdge-based application, I tried just to use a very simple case, like to use just a table, and based on that table to generate a full application from zero, like a REST service. But if you have like multiple tables that are linked together, here you also have to change the code behind to have like a different logic behind to, I don't know, to customize your templates so that you can have those tables linked together.
Yes, I see. Thank you very much. Another question, when you have really a lot of data, it's not useful to fetch them all together. So sometimes you need some paged fetched. How would you do this here with this query extension you have?
Yes, so you can also generate different type of customized classes. So for your example, you want just to fetch just small parts of data.
Yes.
And in this case, well, you can you can add this logic in your templates, and that logic for getting the data just in small pieces will be generated when you generate the code. If you want, you can also add like some visual stuff in the model, just like an option to have your data in small pieces, like just give me the first 10 data, then the second one, the third one, you know?
Yes, thank you very much. Thank you.
So you can personalize it how you want.
Thank you. I see Adam has a question.
Yes, how hard it is to make the template, and what happens if you customize the generated code?
Okay.
So if you mentioned that it is advised to start from a model. So if you change something, regenerate the code, change the model and regenerate the code. What happens if you have custom code written and you regenerate everything?
Well, you are also able to regenerate the code. So with Axiro, the tool that I've used, you can create some, let's say, protected zones in your templates. And when the code is generated, you have some areas in the class that can be changed by the regeneration, and some areas that will be, let's say, dumped. And you can use those protected region to regenerate the code. So the code that you have already wrote in some of the classes won't be affected when you regenerate the code.
Because I have to mark that piece of code that I would like to protect, for example.
Yes, so
okay.
Also, after you generate the code, you can also define by yourself some custom zones in your class. And after the regeneration, you won't lose that part.
Okay, and to set up the template, how much time it take?
Well, it's like, I think it's the same time as you would write the code manually. So for the template, you just have to write the code in your own programming language. So in our case, you write OpenEdge ABL language. And you also need to add some conditions there. And those conditions are written in AQL, in advanced, in Axilo query language. And you can also use Java here. And maybe it is more complex to use Java here, because for more complex tasks, it's better to use Java to have the code generated exactly how you want.
Okay, thank you.
Thank you. I received another question. Is it possible to integrate MDE into an existing project?
Yes, we can integrate MDE into an existing project, but we want that, well, our model to reflect our code, and also the code to reflect our model. And in this case, we don't have any model because we want to integrate our existing project. So in this case, we might have to create like a reverse engineering function that looks on all the classes and all the methods in our project. And based on that, it will generate our initial model. Afterwards, we can just use the model to create new functionalities or manual code if you want.
Okay, thank you. I think we're getting close to our allocated time. Well, I hope the information Catalin provided is useful and relevant for you and your projects. Thank you, Catalin, for the demo and for the presentation. If you have any other questions related to the concept or on the demo, feel free to contact us by mail, webpage, or social networks. Yeah, thank you for joining our webinar. I wish you a very great day and see you on our next webinar. Thank you.
Thank
Thank you very much.
for joining.
Bye-bye. Thank you, guys.